Good afternoon, everyone.
Yes,
Yagnesh sir,
Dr. Milind.
Patel sir, can you hear me?
Yes, yes. You can keep your camera on, Dr. Milind. Yeah, it's nice to see you after a long time.
So very good afternoon to all participants on day 2, session 3. So I would like to request Professor Nikunj Yagnik to introduce our speaker, today's speaker. Yes, Nikunj sir, please.
Good afternoon, everyone. Uh, Respected head of department and respected our today's speaker, Dr. Yadav. It's great honor and my privilege to introduce our today's eminent speaker, Mr. Professor Milind Yadav. He is working as a professor in Department of Mechanical Engineering at Finolex Academy of Management and Technology, Ratnagiri, Maharashtra. He has completed his MTech in mechanical engineering with specialization in automobile engineering. He has completed his PhD in mechanical engineering with specialization in alternative fuels and engine optimization. He has published more than 26 national, international peer-reviewed papers in variety of journals. He also received grant from Konkan Railway and University of Mumbai. He has published one book on novel variable compression ratio engine. He has more than 21 years of teaching experience and guided more than 6 postgraduate students in the field of automobile as well as mechanical engineering. He delivered more than 25 technical, non-technical talk in variety of STTP and FTP across India. Now, I request Professor Dr. Milind Yadav to take over this session and kindly energize with your wisdom and expertise. I request Professor Dr. Milind Yadav to take over the session. Thank you very much. Milind sir, are you there?
Yes, sir.
Please.
Sir, shall I start?
Yeah, please carry on.
It's good afternoon to all of you. First of all, I would like to thank you, Dr. Sanjay Patel, sir, for inviting me to deliver this particular session. He's constantly inviting me and giving me an opportunity to deliver the content. So, first of all, at the outset, I'm really thankful to Dr. Sanjay Patel, sir, for giving me this particular opportunity and entire team of AD Patel Institute of Technology. Well, without wasting time, let's begin for the session. I'll be switching off my camera just to make sure that I'll be able to present it effectively. Will it be fine, sir? Will it be fine?
Yes, yes, it's okay.
Yes, sir. Yes, thank you. Thank you very much.
That's up to you. I mean, if you want to keep it on, you can on.
Yes, sir. Yes, sir. Definitely.
Yeah.
Let me switch off the camera and let me share my screen. Now, I just want confirmation from your end whether the screen is visible to all of you or not. Can somebody tell me whether the screen is visible?
Yes, yes.
Yes. Thank you. Thank you, Agnish sir. So the topic for today's discussion is obviously futuristic automotive technologies. So already I have been introduced, but my name is Dr. Milind Yadav. I'm professor at Mechanical Engineering Department. And the topic that we'll be discussing today is futuristic automotive technologies. Let's begin with the contents of today's presentation. These are the topics that I'll be covering. Right at the beginning, I'll introduce you to history of automotive sector development, a brief history, obviously, because that is the title of the topic. Then I'll come to the core part of the discussion directly. I'll try to introduce to the top 10 automotive industry trends. So how the automotive industry has evolved from its history to the current state. Then taking reference of those top 10 automotive trends, I'll come to the core part of my presentation, which is obviously ADAS system, which I'll be discussing, that is Advanced Driver Assistance System. And in that Advanced Driver Assistance System, I'll just try to cover up system which are to be controlled by ADAS, then sensors, and how those sensors are positioned as far as automobiles are concerned, how the entire system is basically integrated, what are the features, what are the different levels of autonomy, and finally I'll come to the current status of ADAS systems. I'll try to give the global perspective as well as the status of autonomy as far as our own India is concerned. Then I'll switch over to the second topic which I'll try to discuss today, and that will be micromobility. Initially, I'll try to talk about the need of micromobility. Then I'll try to classify the micromobility vehicles depending upon Society of Automotive Engineers, and couple of features that too I'll try to discuss. And then finally, I'll come to the advantages and challenges of this particular technology. So it is the session which is planned for 1 hour 15 minutes odd, and the last 15 minutes are obviously dedicated to question and answer session. Chala. I'll be using pen and pencil. That is my basically style. So I hope everything that I'll be doing will be something like this. So please get used to it. Now, let's move on to the first point of today's discussion, that is history of automotive sector. How basically the automotive sector is evolved. It basically takes me to, 16th century, basically. And before that 16th century, rather, the automotive sector, before commencement of this particular sector, obviously, it basically started with this one, right? Every one of us knows what is wheel. Invention of a wheel has contributed a lot as far as this automotive sector is concerned. So it basically invented in Paleolithic era. It is close to 1500 to 750,000 years ago, right? And then this has been evolved and used for a number of practical applications. And after that, somewhere obviously it has been used for applications like pottery and all. Probably you all must be knowing about that. and then they started using this wheel for transportation purpose. Initially they come up with obviously sail mounted carriages. I hope you know what you mean by sail is. Well, sail is something like a ship with clothes on it, right? And then by taking wind force, with the help of wind force, we basically try to drive that. That is that. I hope you must be knowing the word sailing, right? So initially we used to have vehicles with sail. So they used to call it as sail mounted carriages. So there it is basically begun from there. Then somewhere in the 17th century, we had a steam engine propulsion system, and in between they shifted from the cell mounted carriages to animal carriages, right? We use different animals to drive vehicles. It started with horse, then it bullock. I hope you know that, right? So in between they use this one, and in early 80s, in early 18th century rather, we come up with horseless carriages, and obviously we started using alternatives. We started using steam as a main fuel to propel the vehicles. uh, Somewhere in the late 18th century we tried to shift from steam propulsions, and we'll try to find out the alternatives to the steam propulsion. And major reason for that was obviously, we know that this basically steam engines are basically, we know that these are obviously external combustion engines, right? And then there are a lot of disadvantages going for external combustion engines. They take a lot of space. There is issue related to calorific value and everything. So obviously we shifted from external combustion engine to internal combustion engine, which are more compact in their shape. The calorific value for gasoline, for diesel, for different gaseous fuel was much higher obviously, and we could accommodate these prime movers in a very limited amount of space, right? Then obviously came 1876 rather, and in 1876 basically human invented the first four-stroke engine. In 1876 we basically invented the first four-stroke engine. Then in 1885 the real development started rather. The first practical automobile with petrol engine was obviously built by Carl Benz in 1885. Benz was granted a patent for his automobile way back in 1886, and then he began the first production of automobiles in 1888. uh, well, his wife later on also proved with a first long distance trip in August 1888. I mean, recently there was one video which was roaming around the social network everywhere. Well, that was basically belonging to this one, and it has been shown that the horseless coach was absolutely suitable for daily use. So that was basically the first development of automotive sector, from where it was started. And then 1819 to 1910, these are extremely crucial years in the history of automotive industry. Actually, industry at such started in this particular era itself. So during the 1910s, the development of technologies and the societal infrastructure continued, in addition to the new manufacturing practices. So as far as technological developments like steering wheel came into existence, floor mounted accelerator came into existence, and that made this particular vehicles more driver friendly, made it a little driver friendly. Together with that, driving license were issued, then service stations were opened, self infrastructure started, and even banks started offering loan facilities for obviously the buyers. In the same rather era, I probably all of you must be knowing that somewhere in 1906, Ford came up with his famous Model T, right now, and well, the mass manufacturing concept was introduced by Henry Ford way back in 1920. I mean, if I have to give you the precise number, then is obviously 1913, where basically the concept of mass manufacturing is started. It is basically scaling up the production. Ford, rather, during those days, Ford also introduced the concept of using interchangeable and the standard parts, and that further pushed the development of this particular sector. Simultaneously, during this time itself, the infrastructural developments like a road, then traffic lights, these two carried on. Then in 1920, rather from 1920 to 1930, this is known to be era of mass production. This is known to be era of mass production, and lot of rather variety of automobiles were available during this particular period. So almost all the manufacturers, like let it be Benz, let it be Daimler, let it be Chrysler, Ford, all were involved in this particular mass manufacturing, where the Ford basically stick to the concept of single model, that is Model T, where the General Motors those days adopted a new production technology, and they have they come up with lots of models, and they basically created the variety for the buyers, and that helped the company to increase its market share. After that, from 1930 to 1940, new market players enters into this particular market, like Continental, then Volkswagen. Even this particular period, the merger of different companies took place, rather. Benz and Daimler merger, or let it be Chrysler and Dodge merger, right? These mergers also take place in this particular period. Then 1940 to 1950, this is basically the era of hello, am I audible?
Yes, sir.
Hello?
Yes, sir. Yes,
Sir,
sir.
am I audible? I'm just
Yes.
confirming.
Yes, yes, sir.
Yagnesh sir, am I audible?
Yes, sir. You are audible. You are
Hello?
audible, sir.
Hello?
Audible, sir.
You are
Hello?
audible, sir.
I'm audible, na? There is no problem, na?
No, sir. Continue, sir.
Yes, sir. Thank you. Thank you very much. Thank you very much. So let me go back to the presentation. So this is the point that we discussed, and then there comes the era of obviously Second World War, which took place basically from 1940 to 1950, and during this period, obviously the entire automotive industry were used for the development of I mean war equipments, obviously. So those days, obviously, war equipments were manufactured using this automotive sector. 1950 to 1960 is typically called as era of technological developments, like the technologies like fiberglass bodies, high compression ratio engine and fuels, vehicle comfort, look and feel, emerging safety and environmental regulations, speed limits for the vehicle, seat belts, then heating and refrigerating equipments were obviously introduced into this particular era. And then during 1970 to 1980, we all know environmental regulations came, and emission norms came into existing. During this period itself, a part of the globalization actually starts, and the car exporting also start, especially from Japan to US, and in 1980 to 2000, actually globalization started. Especially in India, you must have seen we are little late as far as globalization is concerned, but still it basically started with mobile manufacturing way back in 2000, 2001, and then slowly we are coming up close to the automotive sector. So this is basically how the automotive sector has evolved, right? Obviously there are number of step must have been took place in between, which I could not cover, but this is just a brief introduction. Now if you think of the top 10 automotive industry trends, then Start US Insights has given us this particular number. If you look at this particular number, these are basically top 9, or you can say 10 automotive trends. Now the major contribution is basically from autonomous vehicles. So here you will find this number is huge, right, compared to all others, and least amongst all is obviously this one, and that is Internet of Things, IoT. We all know that. So autonomous vehicles is now taking over the charge, right? Autonomy is going to be the future. Then there comes the second one is obviously connectivity. A lot of things are also happening in this particular sector. Then the third one is electrification of vehicles. Now, well, obviously, I'm not going to talk about electrification. Dr. Sanjay Patel will be delivering his exclusive session on this one. I think it's scheduled tomorrow. Then the fourth one is shared mobility, this one, which is contributing 14% of that top 10. Then there comes artificial intelligence, AI. Then there comes big data analytics. Then there comes HMI, human machine interface, blockchain technology, and all. Now, talking about these technologies, as far as my concentration is concerned, my concentration will be on these two sectors. As far as today's presentation is concerned, so initially I'll be talking about not I'll be talking about the autonomous vehicles, but my concentration will be on ADAS, which is Advanced Driver Assisted System. That is what I'll be talking about, and how it is going to take us to the autonomy. That too I'll talk about. And then in later on in my presentation, obviously I'll be talking about the shared mobility concept as well, which is also going to be the future. Now, talking about all others, if I try to throw light on some of the others, especially this one, well, which are not in highlight as far as Indian automotive sector is concerned, but these are going to play a very crucial role in the coming days. Like, you can think of blockchain chain technology, you can think of even big data analytics, or you can even think of Internet of Things. So in near future, you'll find these numbers are significantly going to grow. Now, as far as blockchain technology is concerned, probably you must be knowing what is a blockchain is. So I won't be talking about that, but how it is basically useful in automotive sector, that I'll talk about. As far as the blockchain is concerned, every vehicle will be given with a digital identity, and the every vehicle which is running on road will be having its own digital identity. So thus now the car can pay for the use of the infrastructure on the road when they go on, basically. Let it be I mean, toll booths or whatever it may be. The cities will be also able to charge for the consumption, the carbon emissions as well. And on the other side, the car owners can sell their seats, right? If they're traveling from one place to the other one, then obviously they can offer those share mobility concept, sharing of seat rather. It's not share mobility. Then they can allow others to charge their vehicles driven by obviously batteries if their own vehicle is not in use, and they can also report flaws of infrastructure or accidents. So that these are the things which are proposed as far as blockchain technology in the automotive sector is concerned. Talking about Internet of Things, well, this is once again going to revolutionize the entire automotive sector. Internet of Things is basically refers to the connection of billions of complex devices, maybe electronic sensors, or maybe gateways, or maybe actuators, whatever it may be, or maybe platform hubs or something like that. And these devices basically can connect and interact with each other over a wireless network. Uh, these obviously can share the data, and with the help of this data sharing, it is possible for us to manage lot many things. I mean, this can be useful as far as fleet management is concerned, with where you can identify the location of the fleet, you can identify what amount of weight is carried out by that particular fleet, and you can manage that particular weight. You can calculate the route, you can calculate the fuel average performance, and lot many things. As far as Internet of Things is concerned, there is one more technology which is coming up, probably you all must be knowing, and that is connected car technology. So we are having 4 different sectors in connected car technology. You can have V2V, that is vehicle to vehicle, where it allows you to share data within the vehicles, right? The data mainly constitutes information related to the location, related to the speed, and that helps basically in preventing accidents, right? And allow emergency vehicles, maybe something like that, maybe ambulance or fire truck, something like that, to reach to the required destination at the earliest. So that basically belongs to V2V. Then as far as V2I, that is the second one, as far as connected car technology in Internet of Things is concerned. As far as V2I is concerned, it is vehicle to infrastructure, which refers to connection of vehicle and obviously infrastructure. Infrastructure which is related to traffic, maybe lane marking, maybe toll booth, and this will facilitate us smooth traffic flow, right? Because congestion is extreme. Congestion is a lot of creating a lot of problems as far as traffic management in metropolitan cities is concerned. The third one in this one is V2P, which is vehicle to pedestrian. The pedestrian can use these applications to locate the nearby taxis, monitor the estimated time of arrival. This is being used in India. As far as this V2P infrastructure is concerned, it is being used in India. Probably you must be knowing Ola, Uber, which are being used in metropolitan cities, where with the help of simply a mobile app, you can book a taxi, you can call that particular taxi driver, you can share his and your own location, and lot many things, right? So that is the third one, which is typically called as V2P. And then the last one is V2N, which is vehicle to network. This is basically an intelligent transport system where the weather forecast department can also connect in, and it can give alerts to the driver about the change in weather conditions and accident on the route or whatever it may be. So that is basically a Internet of Things. And talking about this one, it is basically the blockchain technology. Sorry, not blockchain technology, rather. I already had a discussion regarding this one. This one basically big data and analytics. So you'll be connecting lot of data through GPS sensors, through cameras, right? And these data will be used by different agencies, maybe car leasing agencies, to once again for the moment, to predict the moment. Then these will give information regarding mileage, driver skill, driving pattern, and that data will be given to the insurance companies, right, for the warranty purpose, for the maintenance, for the predictive maintenance purpose, and lot many things, right? So even if in this one probably you see the number right over here, right, but slowly, needless to say, these numbers are also going to increase in near future, no doubt about that. Now, like I said, initial phase you expect to grow it in this particular direction, right? And we are already started working on autonomous vehicle connectivity, and lot many things are happening as far as electrification is concerned. And this sector, shared mobility sector, is basically just begin in India. Probably you must be knowing Yulu is the Bangalore-based company which has entered into this one. So my concentration will be on the first and the fourth point as far as today's discussion is concerned. So let's start. Uh, the point that I'll be discussing initially is Advanced Driver Assistance System, and that is ADAS. Now let us try to understand what is basically need of ADAS, right? That is an important factor. Now, if I refer to the number of accidents which took place, right, and the causes for those accidents, then this is the data. Jumping the red light, obviously we all know we are following a typical red, green and amber light signal system, and jumping of red light is strictly prohibited. But especially in India in 2018, 4,441 accidents were recorded in 2018, and 4,443 accidents were recorded in 2019. That comes to 1% each of the total number of accidents, right? And those occurred basically because of jumping of red lights. Then the second major cause was obviously use of mobile phone. Total 9,000 accidents took place in 2018, and 10,000, close to 10,000 took place in 2019, and that contributes to around 2 to 2.3% of the total number of accidents. If you think of the drunken driving and consumption of alcohol and drugs, then total around 12,000 accidents took place in 2019, 18, and the number includes to close to 12,000. It is not 2,000, very sorry, 12,000. So 12,018 in 2018 and 12,256 in 2019, and that contributes to around 2.6 to 2.7% of the total number of accidents. And then progressively you'll notice the number is growing on. Now, driving on from wrong side or lane indiscipline, total 24,781 accidents took place in 2018, and number is very similar, 24,431 in 2019, and that comes to 5.3 and 5.4%. And here is the huge number. As far as overspeeding is concerned, in India, total 3,10,612 accidents took place in 2018, and 3,928 number of accidents took place in 2019. And that number, look at this percentage. This percentage is huge. There is 66.5% is in 2018 and 71.1% in 2019, right? Now, if I put them together, this is this plus this plus this plus this comes close to 80%. This will come close to 80%. And where goes the remaining? So remaining 20% includes the accidents or fatalities happening on account of reasons other than human error, right? Now that may include road environment or condition of the vehicle, whatever it may be, number of reasons for that. But these are the one which are contributing as far as human errors are concerned. So by and large, it is well understood now that majority of the accidents which are taking place are basically because of the human error, right? And then this is what World Health Organization report says, right? If you look at the number of the reasons, top 10 reasons of human death occurring all across the world, then the first one is obviously the heart disease, which is contributing 14.2%. Then cardiovascular diseases are contributing 12.1%. Liver diseases are contributing 3.8%. And in this one, it is this is data obviously from 2004, right? And look at this one. Ninth place is taken up by road accidents, and it is hardly contributing 2.2% in 2004. This is WHO report, and it says that by 2030, this number 9 position will shift over to number 5 position. So progressively, the deaths due to road accidents, right, the fatalities due to road accidents are going to change significantly, and there will be a lot of death occurring. Now, what is the solution to this one? Like I said, the majority of the accidents were taking basically because of the driver. Like I said, the 80% are taking place because of the driver and the mistakes which is caused during the driving. So in order to prevent that, we are going to have a semi-automatic or a fully automatic control system, vehicle control system, that will not only take care of the comfort, but it will also take care of the safety of the passengers as well. So here it is proposed to have a either semi-automatic or a fully automatic system which is going to control the vehicle. Now, as far as controlling the vehicle is concerned, we can have two types of controls. Either we can have a longitudinal control, and then you can have a lateral control. Now, as far as longitudinal control is concerned, well, this is typically referred to speed control. This is typically referred to the speed control. And if you think of the lateral control, this is basically referred to the steering control, right? By and large, we'll try to control these two things. Not only these two things, but we'll try to control few more systems rather, as far as automobiles are concerned. So these are the overall systems that we'll try to control with ADAS, right? So you can have a control over a braking system, you can have control over a steering system, you can have control over the suspension system, you can have control over the powertrain, you can have control over the battery systems as well. So all in all, this ADAS, advanced driver assisted system, can literally control these many systems as far as automobiles are concerned. Now let's slowly progress through. In order to control, obviously you need some data, right? So when the system when the vehicle has to take a decision whether to stop the vehicle or whatever it may be, or when to have a lateral or a longitudinal control over the vehicle, then you should have some data from the surrounding, right? And to capture that particular data, your vehicle will be loaded with lot many sensors. Your vehicle will be loaded with lot many sensors. Now this figure basically gives you an idea about the different types of sensors used along with their locations, uh, so starting with this one, there is a radar, there is lidar, there is front camera, then there is rear view camera, then there is short range radar, right? Then there is a surround view, which refers to the satellite camera, then there is driver monitoring camera, and too many of them. Now for what purpose they'll be basically used, right? Now I hope you are familiar with this one. I think you are familiar with the camera, you are familiar with radar. As far as lidar is concerned, it is basically light detection and ranging technology. It is little bit costlier than that of the radar. So hardly few vehicles you will find will be loaded with this type of lidar technology. Now, for what purpose we'll be using this sensors? So let's try to have a little discussion regarding this one. As far as a radar is concerned, which is basically a long range radar. There are two types of long range and short range. Obviously, most of the time the long range radar is loaded onto the front side, and the short range radar is basically loaded onto the rear side of the vehicle. As far as long range radar is concerned, this is typically used for the adaptive cruise control and obstacle detection. So if at all there is any obstacle coming in front of the vehicle, it will be automatically detected by LRS, long range sensor. I'll be talking about adaptive cruise control as a feature of ADAS in my coming slides. Then talking about LiDAR, the light detection and ranging, this will be used for emergency braking. This will be used for pedestrian detection. This will be used for collision avoidance. This will be used for the detection of the distance and the speed of the vehicle. And it is also going to help us in detection of the obstacle. Now, where is the location? This is most important rather. The long range radar is loaded somewhere over here close to the bumper, front bumper obviously, and LiDAR is located somewhere over here. Most of the vehicles also uses this particular position for GPS signal, rather GPS sensors as well. Probably you must have seen it in so many number of vehicles. Then there comes the cameras. Obviously, it basically uses front camera and as well as the rear camera, and both these cameras are used for the vehicle detection. It is also useful to identify the blind spots. It will help us. It is going to help us in parking and identifying the traffic lights as well. Then there comes the short radar. As far as short radar is concerned, this is typically used in case of vehicle park assist. Once again, I'll be talking about this one as a feature of ADAS. Then as far as the next one is concerned, that is surround view cameras, which are typically called as 360 degrees views, and those cameras are literally loaded everywhere. I mean, even on the front side, even on the right corner, left corner, below your rear view mirrors, right, and even on the rear side. And basically they try to give you 360-degree view, which is typically called as surround view around your car, right? So these are basically the cameras and the radars through which basically, and LiDARs rather, through which we will be creating an virtual environment. Rather, car will try to identify that particular virtual environment for obviously decision making system, for decision making rather. Now let us try to understand how these are basically integrated, how these all systems have been integrated. So like I said, you'll be using lot many sensors over here. I already talked about that. You'll be using cameras, you'll be using radars, GPS for navigation, and other sensors, right? And these sensors are going to give surrounding information to obviously the vehicle. And then you will be having one controller that is typically called as the ADAS controller, and that ADAS controller is likely to give signals to the driver, and if the driver doesn't respond to the signals given by the ADAS controller, then even it is possible for it to actuate this system. These are the systems that we already talked about, right? Well, it can control the braking system, it can control the steering system, suspension system, powertrains, battery systems, and a lot many of them. So this is how basically the systems are going to systems are integrated basically in ADAS. Now what we'll try to do now, the first and the most important one, as far as these warnings are concerned, if I think of the warning which are given to the driver, well, the warning will be in a form of a sound. So there will be exclusively speakers which are going to create a noise. Well, before that the dashboard signals are going to activated. If at all driver is alert, then he can take the decision depending upon the signals on the dashboard. If not, if the driver is not responding to the dashboard signal, then the warning sound will be given. And even if driver doesn't respond to that sound, then in some of the vehicles it is possible for you to have vibrating seats or even vibrating steering column, with the help of which your car will try to give warning to the driver. And even if driver doesn't respond to any of them, then obviously the vehicle will take its control. Rather, the ADAS controller will take the control of the vehicle, and depending upon requirement, it will try to activate any of this particular system. Most of the time, the control will be taken with the help of this one, obviously the braking system, right, in order to prevent accidents. So this is how basically the system is being integrated. Now what we'll try to do, we will try to understand the features of ADAS, right? Now, some of you might call this as different types of ADAS or whatever it may be. I normally call this as obviously the features of ADAS. And the first and the most important feature of ADAS is obviously adaptive cruise control, which is typically called as ACC, adaptive cruise control. Now, in this particular case, you'll be having two vehicles, obviously. Your own vehicle, which is typically called as an ego car, and then there is one more which is moving ahead of your vehicle, and that is typically called as a lead car, right? Now, all of you must be knowing about this particular word, cruise control, right? Now, what do you mean by cruise control? This is basically the system which will try to maintain the speed of the vehicle, which will always try to maintain the speed of the vehicle irrespective of the road condition. So you can literally fold your legs and you can simply have a control of the steering and you try to put your vehicle in the cruise control mode, it will carry on, right? But adaptive cruise control is little bit different than that of the regular cruise control. Now, while in cruise control, the vehicle will continue to run at a desired speed irrespective of the road condition. When the system comes out of the cruise control, if you are going to brake the vehicle, then it automatically comes out. We all know that. Now, as far as adaptive cruise control is concerned, well, this is now once again becoming popular as far as Indian automobiles are concerned. It basically tries to maintain the safe distance. Now, if you refer to this particular figure, you will notice that there are two distances over here. The first one is the safe distance, and the second one is the relative distance. Now, in the first figure, you will notice the ego car, that is our car, is travel at a driver's set speed, and this refers to obviously the cruise control. Right now, now you'll notice this particular distance. Look at this one. This is basically the relative distance between the ego car and the lead car. Now, once ego car crosses the safe distance, now what you'll notice right over here, look at this one. This is basically the safe distance. Now, the ego car, the distance between the ego car and the lead car is now equal to the safe distance. And now, if your ego car or your own car is going to cross this one, then obviously it will be noticed that the relative distance between the car is now significantly dropping down, and then immediately the ADAS system and ADAS controller is going to come into picture, and then it will try to brake the vehicle automatically, and it will try to maintain this particular distance. Now, if the speed of the lead car increases further, then automatically you'll notice this particular relative distance is further going to increase. And if this relative distance increases beyond the safe distance, then once again the adaptive cruise control system will try to increase the speed of the vehicle, and it will try to maintain in a regular fashion as that of the regular cruise control. So this is now coming up as probably the best feature of vehicles which are equipped with ADAS, and that is the first one. It is adaptive cruise control, ACC. Moving on, the second one is AEB, which is typically called as autonomous emergency braking. Now, let me play this particular video so that you'll be having a brief idea. What you see right over here is this is basically the road. The vehicle, your own vehicle, is traveling in this particular direction, and what you see right over here is the pedestrian, and he's basically handling this particular mobile, obviously not having any concentration on the road, and he is basically trying to travel across the road. He's basically trying to cross this particular road. Now look at what's happening in this particular case. So let me play this your video. Vehicle is coming across, the pedestrian is moving ahead, and then if the driver is not going to respond, the vehicle will be braked automatically by obviously the ADAS controller. Now, if I play it one more time, please look at this one. The vehicle is moving ahead, the pedestrian is moving on. The vehicle detects the pedestrian, and if the driver is not going to respond, then the vehicle will be put into emergency braking system, into emergency braking. Now you must have understood the situation. If I go to this particular figure, now the situation is very similar to that of the adaptive control, right? What you see right over here, this is basically the lead vehicle. What you see right over here, this is basically the ego car or ego vehicle. Now the ADAS system will constantly monitor the speed and obviously the deceleration rate after applying the braking. So once again, same situation. Look at this one. Now the relative distance between the lead vehicle and the ego vehicle is dropping down, right? What is going to happen? Initially, it will try to blink the signal onto the dashboard. It will try to give warning through lights and through sound system. But if driver doesn't respond to that, then for initial phase, look at this one. For initial phase, it will try to apply light braking, and afterwards it will obviously try to go into the emergency braking, and it will always try to maintain the safe distance between the lead car and the ego car. So the same situation once again, if your lead car is halting at a position, then obviously there is possibility of the collision between the ego car and the lead car, and if the driver is not going to respond to the signals, then the AEB system comes into the picture, and it rapidly goes for the emergency braking. So that's the second one, which is AEB. Then the next one is forward and reverse control warning, which is FCW or RCW. Now this figure is basically taken from Volvo. So courtesy of this particular figure goes to Volvo. Now what you see right over here is same situation. Once again, this is basically your own car, right, which is in white color, and you are trying to take it either reverse, or you are trying to take it outside the parking lot, whatever it may be. Especially you are taking it outside the parking lot, and let us say there is one vehicle which is coming from this particular side. Obviously, once again, ADAS controller and those number of cameras which are loaded all around the vehicles and the proximity sensors, they are going to detect the obstacle. And once again, same thing is going to happen. If driver, initially the warning lights are going to display, then the signal will be given to the driver in the form of a sound. But even if driver doesn't respond to that, then obviously FCW or RCW is going to come into picture, and it will be activated, and automatically braking is going to take place. Now this system has been already introduced in many of the cars, right? Well, nowadays you must have noticed that the number of cars are fitted with proximity sensors on the rear side, right, together with the camera. So this is basically the part of that particular system itself. But in case of ADAS, the next step which is taken forward is to apply the brakes, right? And that is FCW or RCW, forward or reverse collision warning. Then there comes autonomous park assist. This is also very famous. I mean, lot many vehicles nowadays are equipped with this one, which is APS, auto park assist, or autonomous park assist. You may call this as. Obviously, the system is loaded with the display and the cameras, right? There will be cameras on the front side. There will be cameras on the rear side as well. Now, whenever your vehicle is driving and you are in search of a parking lot, right? Most of the time, the driver is going to hit the button inside the vehicle, and then your front sensor, most of the time, the front sensor is going to start detecting for the empty parking slot. Well, that is either with the help of the camera or with the help of the front ultrasonic sensors. It will try to find out the empty or probable parking slot. Well, the system then converts that video footage from the cameras and composites a virtual bird eye view image. Now that you can see it right over here. Please refer to this particular figure. And then this is going to guide the driver along a route to the designated parking position. Now, while doing that, you basically take into consideration the center of radius of gyration of your own vehicle, obviously. That is the first one. Then it also takes, please refer to this one. Please refer to this one. Now it also takes into consideration the interference of the neighboring vehicles. Now, if you look at vehicle number 2 right over here, well, this is the probable area of interference. So it will also take care of that. And together with that, it also take into consideration the trajectory of the vehicle while parking. Now if you look at this one, you will refer to this that it is initially moving in this particular direction, right? And then driver will try to follow this particular trajectory path, right? And then this particular system will literally guide the vehicle by its own to the designated parking slot, right? You need not have to do absolutely anything. The steering and the braking system will be controlled by the APS itself, right? Which is one more and the brilliant feature of ADAS, I would say. Moving on, then there comes blind spot detection system, which is typically called as BSD. By and large, every one of us must be knowing what is BSD, blind spot detection. Now, if you refer to any car, most of the time the structure of the car will be something like this. If I have to draw the structure, now you all are expertise in this one, but still I'm just trying to elaborate the things. So it goes something like this, right? So you'll be having a driver compartment, and then you'll be having a you'll be having engine compartment, this particular part of the vehicle. Then this is basically dedicated to the passengers, obviously. This is called as passenger compartment, and this is typically called as the boot space, right? Now, as far as this construction is concerned, it is basically built on these pillars, right? So here is the first pillar, here is the second pillar, this way, and here is the third pillar, right? So now this is typically called as the E pillar, this is typically called as a B pillar, and this one is typically called as a C pillar. Now, basically, these structures of automotive bodies are creating visual disturbances to the driver. Now, if I refer to this particular figure, now on the front side, obviously, there is a windscreen, right? So this entire portion, close to 180 degrees, this is basically available for the driver, right? Then if you refer to this one, look at this one. Now what comes right over here, there comes the A pillar right over here, right? And that A pillar basically creates a blind spot. Now please refer to this one. So this area is not available or not in the view of the driver. Same is the situation on the right hand side. So there is one more A pillar on this particular side, and then driver is not in a position to view this much area. Then there comes windscreen in between. Sorry. Then there comes glass areas, right, between the A pillar and the B pillar. So this area is basically visible to the driver. This one. This is possible maybe with the help of the left view mirror, or maybe with the help of through window screen, right? Then there comes obviously the B pillar, right? And if you look at this area, look at this one. This area once again falls into the B pillar category, right? And then it is not possible for the driver to see that. So because of structure basically of the vehicle, you will notice it basically creates a blind spots, and then the visibility of the driver significantly drops down. And now who is going to help us out? Obviously those cameras which are fitted are going to help us out. And with the help of those cameras, once again, it is possible for us to create a 360 surround view right on the front of the driver, right? And then with the help of that view, driver can take a decision depending upon the situation. So that is typically called as BSD blind spot detection. Then one more feature is LDW, lane departure warning. Now this is basically the one which gives you an idea about the departure in the lane. Now the cameras which are loaded onto the front side, close to the rear view mirror next to the driver, right at the center, right over here, that I have tried to show right over here. Well, that basically front side, rather front mounted, that basically constantly monitors the lane right over here. Now obviously better infrastructure is required, road infrastructure is required rather, with the help of which it is possible for us to detect these lanes, and simultaneously it detects this particular distance as well. Now depending upon the lateral distance and the position of the lane, if driver is decreasing this distance or maybe this particular distance, then obviously a lane departure warning will be given to the driver. And once again, the methodology will be one and the same. Initially it will try to display the signal onto the dashboard, then the warning through sound system, and then if not responding, then obviously it will go to the braking, right? So lane departure warning is also a famous system, as far as famous feature of ADAS system nowadays. Moving on to the next one is driver drowsiness detection system, which is typically called as DDD. The latest vehicles, I mean, you can think of maybe XUV 700, the recent uh, uh, from rather Mahindra and Mahindra, right? It basically comes with a driver's drowsiness detection system. Now there are different driver drowsiness detection systems are available, right? Even some small simple through Python programming, it is possible for you to detect the drowsiness of the driver. Some systems uses cameras for the drowsiness detection of the driver, and a few systems which are a little bit advanced compared to the one which I talked about. They basically try to analyze the driver's pattern, driving pattern, in the first few minutes of the driving. So starting from zero to first few kilometers, it will try to identify how the driver is basically driving. Then it will try to monitor the steering inputs given by the driver from time to time, depending upon the different road condition, and it also activates for no inputs from the driver. I mean, if at all it sees that vehicle has to negotiate a turn and driver is not responding to the system, still this is going to come into the picture. Well, this system basically takes into consideration the factors like speed, the time of day, the ambient weather condition, how long basically the driver is driving, and too many of them. And depending upon that, it basically determines the tiredness index. And if the tiredness index is larger than the designated value, then obviously the signal will be given in the similar fashion. Well, either it will be a audio signal, or it will be a audio visual signal, or it can be vibration to the seats, or vibration to the steering column, or a steering wheel, depending upon the types of DDD, driver drowsiness detection system. Well, like I said already, in case of XUV 500, basically they have mounted a camera directly onto the front rear view mirror, which is loaded next to the driver, and it constantly detects the movement of your eyelid. And for a certain duration of time, if at all there is no movement of the eyelid, then it immediately brings this particular system into activation. So that's the next one, and it is driver's drowsiness detection system, one more feature of ADAS. Then there comes hill descent control, HDC. Now by and large, the systems works in the similar fashion. Well, whenever it is going down, it always tries to maintain the speed. It always tries to maintain the speed of the vehicle while descending down. If the speed is obviously beyond a certain set speed, then obviously the braking system will come into the picture. If it is coming across a lead vehicle, once again it will try to maintain the distance between the two vehicles, and too many of them. Obviously, the traction control system TCS also helps in hill descent control. Moving on, then there is adaptive headlight assistance systems. This basically comes into picture, especially while night driving. Most of the drivers are having an habit of driving on high beams, right? So whenever a vehicle comes across whenever a vehicle comes across come across a vehicle which is coming in front of it, then most of the time, considering the position of that particular vehicle, most of the time the right hand headlight will be switched to dipper mode, and then the left hand will be kept onto the upper mode, right? So that it is possible for the driver to have a clear view of the left hand road condition, and the driver which is coming, or the vehicle which is coming in front, will not get disturbed because of the high beam, and that system is typically called as adaptive headlight assistance. Now we'll be talking about with this basically I try to give you a brief idea about the different features of ADAS system. Now we'll try to talk about the autonomy levels in ADAS, and what is their current status. What is their current status? Now, all in all, there are total 5 autonomy levels are there. Level 0 is the first one, level 1 is the second one, level 2 is the third one, then level 3 is the fourth one, level 4th is the fifth one, and level 5th is the sixth one, right? So rather, this is basically transformation from zero autonomy to the full autonomy, right? So what I was initially talking about, autonomous vehicles are basically falling into this particular category, that is level 5 of autonomy. Now, what these levels basically stand for, obviously, it is basically the control, which part of the driving is being controlled by the driver, and which part is basically controlled by the system itself. Depending upon that, you try to decide the autonomy. Now, in level 0, obviously, there is no automation at all. There is no automation at all. The driver is in complete control of the entire automobile, and none of the systems or none of the function are basically automated. So driver has to look after each and everything, right? That is typically called as the level 0 autonomy, and it is in existing, far off. You can maybe think of in 1980s, and from there on, right? So driver is having a habit of controlling all the systems. Then there comes level 1. As far as level 1 of autonomy is concerned, this is some sort of assistance to the driver, right? And specific functions are only automated, which involves functions such as maybe steering, maybe braking, maybe throttle control. These are the one which can be automated. Obviously, driver still have the control over the vehicle. Drivers still have the control over the vehicle. So the systems are going to partly automated, but like I said, driver has to control the majority of the things. Now, in this particular case, you can take fit off. If you refer to this particular figure, especially this one, the driver can take his fit off, which refers to obviously cruise control, where you'll be literally folding your legs, and then the controls like braking and throttle will be taken care by the system itself, right? This also exists in market, right, as of now. Then there comes level 2 of autonomy, which is partial automation, and couple of functions are automated, which involves automation of at least two primary functions, which includes cruise control and lane departure warning. Now, by and large, like I said, driver has to, well, he can, what I mean to say, he can take even his hands off the steering, right? As far as level 2 autonomy is concerned, but that is not in all conditions. In majority of the conditions, he has to hold the steering in his hand. But there are certain, like parking assistance or something like that. In those situations, it is possible for the driver to take his hands off. This is already into the market. Well, the data which is presented over there, if you read this one, this came into market in 2013. And as far as India is concerned, we have reached up to this one as of now. We have reached up to this one. You must have heard about MG's Aster, right? Morris Garage Aster. That basically comes equipped with level 2 of autonomy. And there are still 3 levels which are left behind. That is level number 3, 4, and 5. In level number 3, which is typically called as conditional automation, where limited self-driving automation is possible. Right? So even in this particular case, the driver can take his eye off the road, no problem with that. Well, the system take care of. Safety critical functions such as steering, throttle, brake can be completely automized, and level 3 cars needs driver to intervene when self-driving system fails. Now, this is going to be the worst case, obviously. In that particular case, driver has to take care and has to have a control over the autonomy. Then level 4 is obviously high automation, where the system will be completely automated, right? The driver need not to hold the steering, he need not to he can take his foot off from the controls. The cars are designed to perform all safety critical driving functions and monitor roadways condition for an entire trip, not for specific duration of time, but for an entire trip. And driver is not basically expected to take the control of the vehicle in any unexpected situation. Well, this is expected to hit the roads by 2025. And level 5 autonomy, which is full automation, which we call it as complete autonomous vehicle. So that can run without absolute driver. You are not in need of driver, absolutely, right? Drivers are not required. Well, the testing of fully autonomous vehicles are still going on, right? But full-fledged autonomous vehicles are not still running on road. Well, the testing is going on. To some extent, we have obtained the autonomy, right? So probably I would say that we are somewhere lagging right over here. So we are trying to transfer the responsibility from the human to the machine. So like I said, as far as India is concerned, we are lying somewhere over here. Moving on, then we will be talking about these points as far as ADAS systems are concerned. Now, as far as global suppliers of ADAS is concerned, Continental is into this particular business, then Bosch is into this particular business for so long. Whether this particular sector is basically dominated by Continental and Bosch itself. The Denso is also there into this one. Aptiv is also there, Autoliv is also there, Magna is there, and Valeo is also there into this particular advanced driver assisted systems. Well, they are basically the suppliers. Needless to say, they are not manufacturing their own. They are not manufacturing their own vehicles, rather, but they are offering these kinds of systems to the different automotive manufacturers. Probably you must have got to know about this thing, because Continental, Bosch, Denso, Aptiv, Autoliv, these are not into vehicle manufacturing as such, but they are manufacturing technologies, and those technologies will be purchased and adapted by the different automotive manufacturers into their vehicles. So these are basically the global suppliers of ADAS. Talking about the ADAS market growth, right? Well, this is a big market. if I have to give you the data if I have to go directly by the numbers, then this is $24.24 billion industry in 2018. It was rather $24.24 billion industry in 2018, and by 2025, I mean just next 4 year itself, this will have a jump of $91.83 billion. So all in all, it's a huge industry. It's a huge industry, and lots of developments are going on. Talking about ADAS advantages, now by and large you must have understood what could be the probable advantages of this particular system. It basically tries to avoid the human errors, right? From minimize to error-free operation will be possible with ADAS as such. That is basically the objective of this particular system itself, and that takes into care increased road safety as well, right? It is taking control of the entire vehicle if the driver is not going to respond to the road condition which is identified by the vehicle itself. It basically alerts the driver in case of if the vehicle is in case of a problem. To some extent, it is also easing out the driving experience with human machine interface, and this is going to help us out in obtaining heavy safety standards. Now you must be knowing that there is Latin NCAP rating, there is global NCAP rating, right, where the where the automotive manufacturers are struggling to reach to the safety standards, right? So with ADAS, it is possible for us to reach to very high safety standards. Okay, so these are typical advantages. Well, the system also comes with challenges, and the challenges are too many of them. Rather, I have tried to highlighted some of them right over here. The first and the most important is we are still missing efficient database management infrastructure, right? Well, like I said already, the data collected is huge, right? And then you are badly in need of database management system. That data is basically collected from different types of sensors, from cameras, whatever it may be, and then you are badly in need of good softwares to process the data which is received from different sensors. So probably we are still lacking in this particular technological development. The second probably and the most important one, this particular system is to some extent it is proven, but whenever a manufacturer proposed any kind of a ADAS system, then it has to go through 1 million kilometer testing to prove its capability, and this testing is obviously time consuming. It takes a lot of time, right? 1 million kilometers is huge. So that is one more challenge. The next one is the cost of cars. Now, especially if I have to talk about Indian cars, most of Indian automotive sector is basically dominated by hatchback segment, right? And if you look at the cost of the hatchback segment, well, that ranges between maybe 6 to 8 lakhs, right? And if at all you wanted to incorporate ADAS systems into hatchback cars, where the cost is going to range from 6 to 8 lakhs, it becomes a challenging task, right? So that basically a biggest challenge as far as ADAS system is concerned. That is the cost, obviously. The next one is road and infrastructure development. You can have a system with, you can have rather automotive with ADAS, but if road and infrastructure are not good, then probably the system may not be in a position to function as per his expectation. So obviously, it not only depends upon the type of sensor or whatever it may be, it also depends upon the road and infrastructure development. So we'll also have to be, I mean, that is one more challenging task as far as ADAS is concerned. And the not so famous rather, but you really got to look after is this one, and that is cyber security. Now with the technologies like Internet of Things or big data analytics or connected cars, where the cars will be sharing the data with the other car, they will be on a open Wi-Fi platform. Obviously security is going to be a concern, right? Well, there is possibility that the data from your car will be stolen, and they can do absolutely anything. There is possibility, projected possibility, that you can literally hack the car, and you can now, since the ADAS system will be having control over over the steering, over the braking, over the fuel injection systems, over the battery system, right? One can literally hack your car, and I mean, this can be used for different terrorist activities, to be frank, right? So as far as the security is concerned, cyber security is concerned, we really need to work upon that as well. So these are basically some of the advantages of the ADAS system and challenges in front of the ADAS system. In maybe couple of years, next couple of years, most of the Indian automobiles will be also started using this full-fledged driver assisted systems. Okay, now I'll switch over to the second part of my presentation, the technology which I will be talking about one more, and that is micro mobility. Now, as far as micro mobility is concerned, this word, if I try to split this particular word, so it is basically, I should say, it is micro plus mobility. Now this micro stands for small, obviously we all know that, right? Micro stands for small, and mobility refers to the ways of getting around, right? You try to roam around, so it's the smallest possible way of uh, uh, getting around. That is what you exactly mean by micro mobility is. Now what I try to present over here is two photographs, basically not two photographs, datas rather. One is data which is which is given by the Planning Commission of India, and the second one is basically from US. Now if you look at to this particular data, you will understand this data has been segregated by the distances. Look at this one. Let me check this one out. Can you see this one? This is 0 to 5 miles. This is 5 to 15 miles, and this one is 15 plus miles. Obviously this is the data which is related to United States, USA, and on the right hand side this is basically belonging to India. Planning Commission of India has given this particular data. This is for less than 5 kilometers, this is 5 to 20 kilometers, and this is 20 plus kilometers. Now what they have done over here, the total trips, all the entire trips are basically divided into three categories: 0 to 5 miles, 5 to 15 miles, and 15 plus miles, right? In case of US, or in case of India, they have divided into less than 5 kilometers, 5 to 20 kilometers, and 20 plus kilometers. And look at the percentage. Well, it is observed that we basically use either cycles or bikes most of the time, if at all we wanted to travel a distance less than 5 kilometers. Same is the situation as far as US is concerned. Basically they use cycles for shorter distances, and that basically contributes 66% of total trips, especially in India, and it contributes to 60% of total trips in US, right? So bikes and scooters, or maybe walking, even in case of India, right? 66% of the trips falling into less than 5 kilometers. Now if I refer to this one, which is 5 to 20 kilometers, most of the time we try to book a Ola or Uber, whatever it may be, and we try to cover this particular distance, and then that contributes to the 22% of the trips, right, where we try to hire basically the vehicles. And right in this particular case, it is close to 25% in case of US. And then the least is 20 kilometers and above, which is contributes hardly 12%, as far as Indian total trips are concerned, and 15% as far as in US total trips are concerned. Now, you must have noticed by and large the biggest number is right over here, 60% and 66%. So then there comes a point that if at all we are going to have 66% of short trips and hardly 12% of the long trips, then we really need big cars? Well, what is the problem with big cars? Well, problem with big cars is obviously we are going to use only for 12%, right? We are 66% times rather we'll be using cycles or scooters only, right? So they are time consuming, right? Traffic is the issue as far as metropolitan cities are concerned. With the advent of urbanization, the demand of transportations are significantly increased, especially in metropolitan cities like maybe Mumbai or Delhi. You must have noticed these things, right? Hardly, if you wanted to travel a distance of maybe 4 to 5 kilometers, it literally takes 1 hour or even 2 hours. So the traffic congestion is a lot of problem. Together with that, you cannot travel fast, right, due to congestion. Then carbon emission is one more problem, right? And then obviously the cost of ownership, that is one more huge problem as far as owning a car is concerned. And together with that, obviously you're badly in need of the parking lot. Now you must have heard about the topics like slowly in metropolitan cities you will have to show the parking spot, and then only you can own the car. Now what I mean by that over here is, if at all we will be using only 12% of the total trips, why to own a car? And then why not to shift from a big car to a small category of vehicles which will be easy for us to the transportation? Now here I would like to elaborate one story of a cute little car. Now unfortunately I'm not going to take names directly over here, but a famous Indian car manufacturer was trying to develop a cute little car. And then when they decided to launch this particular car onto the market, there was one government authority who literally tried to file a case, suit a case against that particular company, and they tried to stop production and launching of that particular cute little car onto the road. And what was the problem? The problem is obviously, if at all that cute little car, pocket friendly cute little car becomes famous, then there is great possibility of uh, uh, persons opting for this particular car. They will be switching from two-wheelers to the four-wheelers. And if that happens, then obviously the congestion and the traffic problems will become severe in metropolitan cities. Unfortunately, that particular case didn't stand in front of the court. So obviously the battle was won by the car manufacturer. He launched that particular car, but unfortunately that car didn't do good business in the market, and eventually the car has become past now. But what I wanted to highlight over here is, with the advent of urbanization, the transport demands are significantly increasing, and now we need to shift from a traditional mobility to some other mobility ways. And with this, we come across the concept of micro mobility. Right now, like I said, you will be using different types of vehicles for this particular purpose. These will not be vehicles which are similar to cars, right? These will be altogether different vehicles. And which category of vehicles that we'll be using. But before that, let's try to define what is micro mobility. It is basically the smart transportation modes which are either propelled by humans or by electric motors, right, with the speed range well below 50 kilometers per hour. That is basically the definition of micro mobility vehicles, right? Well, it can be driven through humans, it can be driven through electric motors, no problem with that, right? But the speed is below 50 kmph, kilometers per hour. Now let us try to understand what category of vehicles these will be. What category of vehicles these will be. So let's try to classify micro mobility vehicles. Uh, Initially, I'll try to classify it into 4 different categories. They call it as type A, they call it as type B, they call it as type C, and they call it as type D, right? Now, as far as type A is concerned and type B is concerned, these are basically either powered vehicle or unpowered vehicle, and type C and type D are powered vehicle. Powered vehicles means obviously they will be battery powered. They will be battery powered, needless to say. As far as top speed is concerned, for type A and type B vehicles, the top speed can go maximum up to 25 kilometers per hour, not more than that. And as far as type C and type D vehicles are concerned, this can be ranging from 25 kilometers per hour to max 50 kilometers per hour. Now, mind you, if the speed is increasing above 50 kilometers per hour, that is not going to fall into the category of micro mobility. Okay. Then there comes gross vehicle weight, which is GVW. In type A categories, the GVW, that is the gross vehicle weight, falls well below 35 kgs. And in type B category of vehicles, the gross vehicle weight can be from 35 to 350 kgs. And similar is the case as far as type C and type D vehicles are concerned. So the GVW is well below 35 kg for type C vehicles, and it is well between 35 to 350 kgs for a type D vehicle. Now, which categories of vehicle they will be? So I have just tried to show some of the categories over here. This is obviously the bicycle, what you see right over here. Now, what you see this one, this is basically the powered bicycle, battery powered bicycle. I know probably all of you must be knowing about this one. This is typical two-wheel cycle which you try to drive either with the help of a leg or with the help of a battery. Now, it is little bit difficult for us to understand these two. For that, I have purposefully kept these 2 pictures over here. These are basically stands for, these symbols basically stands for Segway and unicycle. So I hope with this picture it is possible for you to understand what kind of categories of vehicles which are talking about. Now, Segways are becoming very popular. Well, they basically use principle of gyroscope to drive this particular battery operated vehicle, right? And you must have also seen videos of unicycles. Well, not so popular as far as India is concerned, but it is popular in European countries. Segways are slowly becoming popular, especially in India, and that too on tourist spot. That too on tourist spot or some of the historical places. They have given arrangement of segways to travel around. Talking about type B category of vehicles, once again same situation. It will be a two-wheeler, rather it will be a three-wheeler or a four-wheeler. Obviously, what you see right over here is obviously passenger carrier, and what you see right over here is obviously a goods carrier. So that's why you will find the gross vehicle weight ranges between 35 to 350 kg. Moving to type C, the category of vehicles will be one and the same. So even if you will find a battery powered cycle over here, or a two-wheeler over here, or a unicycle over here, or even a Segway in this particular category. That's why basically you'll find the GVW is less than 35 kgs. And the last one is this one, which is obviously our own very own electric two-wheelers rather. Now this concept of micro mobility is slowly becoming popular even in metropolitan cities, especially with need of transportation. That's why I'm highlighting this one right over here, for transportation of item deliveries. Maybe it may be a product which is ordered from Amazon or from Flipkart, or a pizza which is ordered from Domino's or whatever, or local supplier, whatever it may be. They have started using this kind of a vehicle. So it is slowly becoming popular in India, but we have yet to achieve a lot many goals as far as this micro mobility is concerned. Now, Society of Automotive Engineers have also classified micro mobility vehicles, so that I'll try to put forward. Slowly, we are coming to the end of my presentation. So this classification is basically depending upon certain features or characteristics of vehicle. So that I'm trying to put it forward. So either it can be a powered bicycle, it can be a powered standing scooter, it can be a power seated scooter, it can be a powered self-balancing board, which I was talking about earlier, Segway. Then it can be a powered non-self-balancing board, or it can be a powered skates, which I was talking about, a unicycle, right? And then talking about the features, I'll try to think of center columns, seats, then operable pedals, then floorboard or foot pegs, and possibility of self-balancing. Now, if you look at this one, then center column is present, seat is obviously present. You can operate it with pedals if possible. Floorboard is possible to some extent, and self-balancing is obviously not possible as far as powered bicycles are concerned. Then powered standing scooters are concerned, center column is obviously there. Seat is not there because it is a standing scooter, needless to say. Operating pedals are not driven, not there, because you have to either drive it by an electric motor, or it can be a human driven. Footboard is present, and self-balancing is not possible. Driver has to balance it by its own. Then power seated scooter, center column is present, seat is obviously present. Operable pedals are missing. Obviously, you can't drive this one because these are heavy in their weight. Floorboard is present, so you can carry a little bit of luggage. Self-balancing is once again not possible. As far as powered self-balance board is concerned, which is typically called as Segways, then center column is possible in some cases. Probably you must have seen on Segways, most of the time they used to have a stand right over here, and a driver can hold it like this one. So it is possible for you to have a center column. Seats are obviously absent because you will be standing while driving. Operable pedals are not required in this particular case because it is electrically driven. Floorboard is obviously there, and self-balancing is possible, right? Because it basically uses a principle of gyroscope. Then comes powered non-self-balancing board. Center column is missing. Seat is not there. Once again, you'll be standing while driving. Operable pedals are also not missing. A floorboard is present, and self-balancing is also missing. And then there comes the last one, which is power skates. Center column is not there. Seats are not required. Once again, you'll be standing. Pedals are missing. Floorboard is there, and obviously self-balancing is possible in this one. So now out of this one, like I said already, this is becoming very popular as far as historical places or tourist spots are concerned. This one are typically used by fleet operators, or maybe suppliers of good suppliers rather, right? This is also famous as far as Indian two-wheelers are concerned. Now we have also started using this one for a shorter duration of time, and even we have started using powered bicycles as well. Moving on, then finally let me talk about the challenges, advantages and challenges once again of this particular technology. Well, the first and the biggest advantage going for this one is obviously it is the most affordable technology, the most affordable. Like I said already, for a shorter duration of time, instead of using a 10 lakh car, it is easy for you to go with a bike of 14,000 or maybe 15,000, bicycle rather, right? Powered bicycle, right? So this is basically a most affordable solution of mobility. I've already talked about the environment. The cars are polluting. Obviously, government, Delhi state government is trying to ban the diesel cars, petrol cars. I hope you must have been knowing about that conspiracy. But if you think of micro mobility, all of these are driven by electric motors. These are battery operated, so obviously they are environment friendly. Ease of congestion in, especially in urban cities, that is the biggest advantage going for micro mobility. You can cover the distance very easily, and that too in a shortest possible time. And this is even it is useful as far as physically challenged persons are concerned. So micro mobility is also used for physically challenged people, not in India but outside the India. So these are basically the advantages of micro mobility. Going for going for challenges of this particular technology is there are no regulations at all. Especially in India, there are no regulations at all as far as micro mobility is concerned. Uh, so with no regulations, obviously anyone can drive absolutely in any ways, and that creates a lot of problems, especially on the road. Then we are having lack of infrastructure as well, right? There is no to some extent in some of the metropolitan cities like Mumbai, Pune, or even in Delhi, some micro mobility infrastructure is coming up. Especially if I take example of maybe Pune, they have created separate roads for bicycles. So it is still under development, but lot of infrastructural developments are still required as far as this technology is concerned. Top speed is obviously a constraint in micro mobility. Like I've already said, that you can't go beyond 15 kilometers per hour. It is restricted. So that is one factor, one challenge as far as micro mobility is concerned. Cargo capacity is obviously one more. You cannot carry huge luggage, especially in type A category of micro mobility vehicles, where we use basically segways, or we use unicycles, or we use battery operated bicycles, where cargo is capacity is the problem. You cannot go beyond certain limits, right? Even if you think of entire range, you cannot go beyond 350 kgs in micro mobility vehicles. That is one more problem. Then there is utility issues, especially in bad weathers. We all know that these vehicles are extremely light, especially type A and type B category of vehicles are extremely light. If the weather conditions are too bad, it is difficult for you to drive this kind of vehicles. And like I've said already, safety is one more issue as far as micro mobility is concerned. Now safety is not only because of regulations, road regulations maybe, but if you look at the structure of this particular vehicles, uh, safety is going to be a problem. So if you, I mean, imagine you are trying to drive a battery operated cycle, or a unicycle, or a Segway, let us say, at a speed of 50 kmph, and then you hit to some other vehicle, right? Well, that can cause serious injuries to the driver, obviously. So the safety issues, not only because of the regulations, but because of the structure of the vehicle itself. So these are some of the challenges of this particular technology. Finally, coming to an end, I would like to say thank you once again for giving me this particular opportunity. I hope I have completed this one in time. So let me come out of the presentation mode. Let me stop presenting the screen. And now once again, I hand it over to Yagnesh sir. Sir, over to you.
Yes, sir. Thank you, sir. any participants having the questions may ask to the speaker, if anyone having the question. Okay, fine. Sir, we conclude this session. So I would like to thank you very much, Dr. Milind, for accept our invitation as a expert lecturer for this faculty development program, and it's really nice informative session and also
Thank you, sir.
helpful to the participants for gaining the knowledge in futuristic automotive technology, especially ADAS and micromobility. So thank you very much, sir, for joining with us and spend your valuable time for your from your busy schedule. Thank you, sir.
Thank you. Once again, on a final note, I would like to thank Yagnesh sir. He was there in constant touch with me. He was sending me emails, invitations, and everything. So, Yagnesh sir, thank you very much. I thank Dr. Sanjay Patel sir rather, because of him I could able to deliver this particular session. He has given me an opportunity to deliver this particular session. And once again, thank you to the entire team of AD Patel Institute of Technology. Thank you. Thank you very much, sir. Thank you.
Thank you.